Hello everyone. Today we're going to be talking about Lechateliers Principle. So the principle states that if a system at equilibrium is disturbed, it will shift to partially oppose that disturbance. So we'll start by looking at the effects of changing the concentration. So if we increase the concentration of a reactant, then the reaction will shift forward. And the opposite is also true. If we increase the concentration of a product, then the reaction will shift in the reverse. So if we have a general form for a reaction here, if we increase the concentration of A, then the system's going to oppose the change and it's going to favor the production of the products or the forward reaction. That's because if we produce more of C and D, there will be less concentration of A. If we increase the concentration of a product, then the concentration of the reactants will increase because the reverse reaction will be favored. So that's the effect on the concentration of reactants and products if either one is changed. Now let's talk about pressure. Now pressure changes apply to a gaseous system. So increasing the pressure shifts the equilibrium towards the side with fewer moles of gas. That reduces the total pressure. Decreasing pressure shifts it towards the side with more moles of gas. So if we increase pressure, or if we decrease pressure, it determines the effect that it'll have on the system. So if we increase the pressure, the system will favor the reaction with less moles of gas. If we decrease the pressure, we'll favor the reaction with more moles of gas. For example, if we have this reaction here to produce water. So if we have this reaction here and all of these elements are in gaseous form, then if we were to increase pressure, let's say that we increased the pressure, the reaction is going to favor the forward reaction because we only have the 2 moles of H2O. So the forward is favored, leading to more H2O gas being produced. Because on the left we have 2 plus 1, which is 3 moles. So we have 3 moles. That reaction is going to be favored if we decrease the pressure. So if the pressure is decreased, then we're going to favor the reverse because there's more moles produced when we have that reverse reaction. So that's the pressure effect. Now we have talked about the effect of temperature a little bit for exothermic and endothermic, so I'm not going to go over that now. But let's see what happens if we have a catalyst in the reaction. So a catalyst is a thing that speeds up the reaction. So it increases the rate of both the forward and the reverse reaction equally. So equilibrium is reached more quickly, but the position of equilibrium and the value of K is not changed. So remember, K is that equilibrium constant. Okay, so to summarize, concentration and pressure changes shift the position of equilibrium, but leave K unchanged. Temperature is the only thing that alters K, the equilibrium constant. Increasing temperature favors endothermic and decreasing favors the exothermic. A catalyst speeds up the attainment of equilibrium without affecting the position or the value of K. All right,